Hello my friends, welcome back to this implementation and mostly welcome to probably the most exciting step of that implementation, because indeed it is now that we define a function that trains the random forest model on the training set, evaluates it on the test set and saves it in a specified S3 bucket, which is of course our model bucket. And of course we're implementing right now these two steps of the pipeline where first Lambda trains the machine learning model in training mode and then Lambda saves the model in S3, meaning our model bucket. Okay, so let's do this. Let's smash this new code section. And as usual, we're going to start with def because we're going to define a new function, which we're going to call train_evaluate_save function. Once again, just to make things super clear. And now, because this is the function that will actually be called to perform exactly that step of the pipeline, well, we have to input, and this is completely compulsory, two arguments which are only specific to Lambda, and which are first event and then context, okay? Because indeed, remember, I told you previously that Lambda is actually a compute service that responds to events. And so whenever a function in the code of your Lambda function is called after responding to a specific event, which could be, for example, a Lambda trigger, for example, when the data comes into our bucket, well, there you go. You have to prevent the event and the context as part of the arguments of that function, okay? And that function you will see is called the Lambda handler. We will see in Lambda that we'll have to specify the Lambda handler at some point, okay? But for now, let's just keep those compulsory arguments, and then let's add some colon, and then here we go. Let's define what this function has to do. All right, so first we're going to get the headers and the raw data, meaning all the data points of our data set. And how we're going to get them? Well, thanks to one of the functions we did before, which is of course the read_CSV from S3 function, okay? Which, remember, takes the data S3 URL. The S3 URL basically of our CSV file, which is an object in our data bucket. Okay, so that's the first step, just to get the headers and the data points. Okay, then we're going to split that data into the training set and the test set. And so I'm going to introduce two new variables, which I'm going to call train_data and then test_data, basically the training set and the test set, and which we're going to get thanks to another function we did before, which is of course the split data. All right, split data, which takes as arguments, of course, our raw data. Okay, our original data set, the data set that comes into our S3 data bucket in the first place. Alright, good. So now we have the training set and the test set. And then what will be the next step? Obviously, it will be to separate once again those training set and test set into the matrix of features and the vector of dependent variables separately. Okay, so first let's get the matrix of features and the vector of dependent variable for the training set, which we're going to call X train and Y trained, right? We're familiar with those. And how we're going to get them? Well, that's of course thanks to our extract features and target function, which will take as arguments what? Of course, the headers and the train data. All right, perfect. That will give us exactly xtrain and ytrain. And now let's do the same for the test set, which is why I'm copying this line of code and then pasting it below, because indeed now we're just going to replace basically train by test. Okay, xtrain here, we replace that by xtest. Okay, then ytrain, we replace that by ytest. And here, train data, we replace that by test data. Okay, perfect. We're making good progress and we're coding this section efficiently. And now, according to you, what is the next step? Well, finally it is to build our simple ensemble model, which is the random forest model, right? It is the simplest form of an ensemble model because it is actually an ensemble tree. Okay, so that you know perfectly how to do. We did it many times before, especially in machine learning A to Z. And so there we go. Let's introduce a new variable which will be exactly our model. And since it's a regressor model, I'm going to call it regressor, which will be created as an instance of the RandomForestRegressor class, which takes as input what? Well, here it's good to specify the number of trees we want in our RandomForestRegressor model, which is given by the parameter n estimators. And let's go with the number of trees used in common practice, which is 100. All right? Perfect. We now have our RandomForestRegressor model. And now the next step is, of course, to train it. So here we go. Same, you know very well how to do this. We take first our regressor, from which we're going to call the method that trains your RandomForestRegressor model, which is, of course, the fit method, and which takes as arguments what, of course? Well, first the matrix of features in the training set, which is of course X train, and then the vector of the dependent variable in the training set, which is of course Y train. Perfect, so that exactly trains our random forest regressor model on the training set. So that's a good thing done. We basically implemented the core of that step in the pipeline. And now, speaking of the pipeline, let's move on to that next step of the pipeline, which is to this time save the model, because we now have a trained model that needs to be saved in our model bucket. So we'll do that in the next tutorial, because it's actually going to be quite technical, so you need a good break and some good energy to tackle this one. And whenever you're ready, let's smash the implementation of that next step.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.